All right, so I've been asked to do problem number 141 on the CP exam. Yes, you can get some water. And that corresponds to honors final exam. I'm sorry, let me back that up. The practice final exam on the honors practice exam is the corresponding number 139. All right, so the question says, what is the molarity? I want to find the molarity. Okay, molarity is the same thing as molar concentration. Molar concentration has the symbol M with a line under it, a capital M with a line under it. And that is the same as putting moles of solute over and dividing by liters of solution. So we need to know when we read number 141 if we have moles of solute or a way to get there, and liters of solution or a way to get there. Now what we have in the problem number 141, it says is, what is the molarity of 22.3 grams of sodium chloride? 22.3 grams of sodium chloride. I hope you can write the formulas for these names. And it's going to be dissolved in 100 milliliters of water. Okay? Now we have a slight problem here that you have to resolve in your own mind. Okay? 100 milliliters of water is the solvent, and we need the solution. And here's how you resolve that. So listen carefully. When you dissolve salt in water, there is very, very, very little change in the water volume. And so therefore, it is a reasonable estimation and close estimation that 100 milliliters of water will also be 100 milliliters of solution. Now, not all salts work exactly like that. Not all things you dissolve in water work exactly like that, but table salt works pretty much like that. Okay? You don't change the volume very much. In fact, if you're really, really careful with the measurements, you can put salt in water and actually make the volume shrink. Okay? All right. Well, careful with the conditions and the measurements. All right. So then we can say that 100 milliliters of water is the same as our solution. So we have milliliters of the solution, but we need it in liters. We have grams of the thing being dissolved, the solute, but we need it in moles. So we're going to have to do some conversions, right? Let's go ahead and put the solute over the solution. We're going to go ahead and put the solute over the solution. The solute is 22.3 grams of sodium chloride. We're going to put the solution on the bottom, 100 milliliters of this sodium chloride solution. Okay? Now the problem ought to be rewritten to say that's a decimal place right there, okay? Because otherwise we're going to end up with only one digit at the end, okay? Let's just do that for now. Yep. What did you put on the bottom?
Well, I mean, I just forgot to put it where my inside sodium.
Well, it's better if you know what you're doing in the beginning. That's all I'm saying. I can count off for it, but if you on the test, you need to know what it means. It would depend. Probably I would count off some small number of points, or 1 point maybe out of whatever the total is for the problem if it were a written problem. On the final exam, it's all multiple choice. So you just have to figure out all the choices, which one best fits the answer you actually come up with. Okay? You have a much better chance of getting it right if you do the work rather than guessing. If you guess, your best score is going to be 25. Okay? Don't guess. Do the work and then pick the best answer to fit your work, okay? 75 questions. All right, we got to convert grams into moles. Guys, we went over this yesterday. Please tell me, somebody can tell me how to convert from grams to moles? Molar mass, I heard it. Thank you, Lord. Thank you. And I do mean that. I'm not being sacrilegious or anything, okay? I'm really thankful that somebody realized that. So, all right, so we got to do molar mass. Calculate the molar mass for sodium chloride, please. Calculate the molar mass for sodium chloride. Everybody can do it, right? Yes. Calculate the molar mass for sodium chloride. Please, do it now. Do it now.
58.444.
Oh, you already got it? All right, so we have 58.443 grams of sodium chloride equals 1 mole. Good for you. Proud of you. There we go. We've got to have an equality statement to build a conversion unit in this class. Good. All right. All right, let's focus up here, Evan. Okay. What?
I wrote stuff on a piece of paper yesterday of how to do that because I forgot, and then I think I looked at it.
Well, I haven't seen it. I'm sorry.
I forgot how to do it.
All right. How am I going to use this to build a conversion unit? What do I do with it? Please tell me. You know. Thank you. Of course, in this class, you have to actually have to show me the work to show how you got this number right here, right? All right. Now, that's going to allow us to cancel, like you cancel x's and y's in algebra. We're going to cancel grams here and sodium chloride here, okay? What goes on the top? The other side of the equality statement goes on the top, 1 mole of sodium chloride. We have the moles of solute on the top. Yay! We've got to fix the bottom now. We've got it in milliliters. How do I get to liters? You've got to know this. You've got to know that 1,000 milliliters equals 1 liter. Yay! What do I put on the top and bottom here? 1,000 on top here because it allows me to cancel the milliliters over here. And I put the other side of the equality statement on the bottom. We have liters of solution on the bottom. Yay! Do the math. 3 point what?
8.568665.
Okay. Now that's moles of NaCl over liters of NaCl solution. And we're going to round this off to, looks like 3 digits. Okay. And we're going to have 3.82. But moles of NaCl over liters of NaCl solution is the moles of solute over liters of solution. So that's the molar concentration. We can use this M with a line under it instead of all of this. That's the molar concentration of the NaCl solution.